Alright, welcome back to Digital Electronics. We're starting out Unit 2 now. First section here, first lesson for that. We're going to talk about binary number system. Alright, what it is, and how to go back and forth between binary and decimal numbers. Okay, so decimal numbers, those are the numbers that we use on an everyday counting type basis. What we use in math class, and what you use in science class, what you use when you go to the store and buy something, that's all of our decimal based system. Binary, alright, is just us being able to communicate with electronics. Alright, we've briefed on it, right? Binary means what? Ones and zeros, right? So for us, bi means 2. Alright, so we're talking about a 0 or a 1, a true or a false, a high or a low. So those really mean something, and we can start to put all those ones and zeros together to make something. Okay, decimal, right, the one we use on an everyday basis, right? Dec is 10. Okay, so like a decade is 10 years. Dec is 10, so it's base 10. Binary is 2, its base is 2. So keep that in mind as we're kind of going through these to help you understand on this. Okay, so we want to be able to take a decimal number and convert it to binary, because that's how we want to be able to communicate with our electronics, send signals, do all those sorts of things. Alright, so how do we do that? Well, we use a process called successive division, which means we are going to repeatedly divide by the number 2, because binary is 2, so we're going to keep dividing by 2. You'll learn it when we do like hexadecimal and octal. We'll be dividing by, like in octal we'll divide by 8, hexadecimal we'll divide by 16. Alright, but since we want to go to binary, we're going to divide by 2. Alright, and the remainder is the LSB, the least significant bit of the binary. Alright, so we're going to just walk through a few of these here. Alright, it's just old school division, only we have to say that things go in evenly, and we either have a remainder or we don't. And it's kind of how we write it. So we're going to do this example here. We're going to convert the decimal number 6 subscript 10. That 6 with a subscript of 10 is telling us that it is a decimal number. If it has a subscript of 2, like we see where there's 110 has a subscript of 2, that's telling us it's a binary number. So the subscript tells us whether we have a decimal number or whether we have a binary number. Decimal, the subscript would be 10. Binary, the subscript would be 2. So we're going to take this number 6 here and convert it to its binary equivalent. So we're going to do successive division by 2. So if we take 6 and divide it by 2, we get 3. Okay? There is no remainder, so we write r equals 0. It's very important that you write these out exactly as you see them here on the slide. R equals 0. Next, we take 3 and divide it by 2. So you're going to always take your answer and keep dividing it by 2. So we're going to take 3 divided by 2. 2 goes into 3 one time, and we have a remainder of 1 left. So we write r equals 1. Then we take 1 and we divide it by 2. 2 can go into 1 0 times, and we have a remainder of 1, and we write that down. So you can see our remainder sitting there. When we write our answer, we always have to write our answer from bottom to top. So we're going to write it from most significant bit to least significant bit. So we're going to write it from bottom to top. So our answer in this case is 110. Do not say 110. It's not 110. It's 110 because we are in binary. Do not say that it's 011. That would be incorrect. 011 represents the number 3 in binary. You have to read it from the most significant bit to the least significant bit. Remember, the MSB to the LSB. When we do successive division, it's from the bottom to the top. So the bottom remainder is a 1. The top remainder up there is a 0. So 110 is how we would do that. Alright, so let's take the number 26 in decimal and convert it to binary. Alright, so we got to do successive division by 2. So we're going to take 26 divided by 2, which is what? 13 with a remainder of 0. Then we're going to take 13 and divide it by 2, which is 6, with a remainder of 1. So we write down r equals 1. Alright, so on and so forth. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. 1, and so on and so forth. Okay? Divided by 2 is 0. So this is really how it works here. So I'm going to reiterate this. We're going to take 26 divided by 2 and get 13. The remainder is 0 because it goes in evenly. If it doesn't go in evenly, we'll have a remainder of 1. If it goes in evenly, we'll have a remainder of 0. Just kind of remember that rule. Alright, so 26 divided by 2 is 13. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. And 1 divided by 2 is 0 with a remainder of 1. That's when we stop. When we can't go back and divide into anything anymore, and we get that 0, that's when we know to stop. Okay? So, remember to read this from the MSB up to the LSB. So when you write this down, it will be 11010. So you must write it in that order or it will be incorrect. Do not go top to bottom. Do not write 01011. You would be incorrect. It must be written from the most significant bit to the least significant bit. Alright, because the least significant bit, remember when we do our truth table, that's the one that constantly changes. Where the most significant bit, that's kind of the placeholder, that's the one that changes the least amount of times. So we have to write the MSB to the LSB, so the solution for this one is 11010. On your homework assignment, if I have you write one in, you do not have to write the subscripts. Don't write the subscript 10, don't write the subscript 2. Also, do not read your answer as 11,010. That is incorrect. It's binary, we actually say the digits. So it is 11010. Okay, so that's what 26 in decimal equals 11010 in binary. Alright, so let's do another example here. We're going to convert the decimal number 41, okay, to its binary equivalent. So same thing, divide by 2. 41 divided by 2 is 20 with a remainder of 1. And you got to go 20 divided by 2 is 10 with a remainder of 0. 10 divided by 2 is 5, a remainder of 0. 5 divided by 2, okay, we can go in 2 times and we get a remainder of 1. 2 divided by 2 is 1, right? So on and so forth. So that's what this one looks out to be, okay? So revisiting everything, you can see clearly how we get our MSB and our LSB and all the digits in between. So 40, we'll go through it one more time. 41 divided by 2 is 20 with a remainder of 1. Okay, then 20 divided by 2 is 10 with a remainder of 0. 10 divided by 2 is 5 with a remainder of 0. 5 divided by 2 is 2 with a remainder of 1, right? Because 2 times 2 is 4. And then 2 divided by 2 is 1 with a remainder of 0. And yes, we do have to do 1 divided by 2, which is 0, giving us a remainder of 1. So our solution here is 101,001. Must be written from MSB to LSB. Okay? Why don't you guys give these ones a shot on your own? Okay? A 13, a 22, a 43, and a 58. So pause the video here and work through them on your own, and then I'm going to show the answers so that you can check yourself and make sure that you're on the right track. Okay, so I'm going to go ahead and display the answers now. So 13 in decimal is 1101 in binary. 22 in decimal is 10110 in binary. 43 in decimal, right, is 101011 in binary. And 158 in decimal is 1001110 in binary. Alright? So hopefully you guys got those right. If not, ask me questions in class. Shoot me an email for those of you at home that need a little extra help on this one. But I think this is fairly, self-explanatory, fairly easy for you guys to comprehend. Just practice. run through the other examples, all right? And I think you guys can get this down. All right, now let's go the other direction. I'm going to give you a binary number, and you're going to take that binary number and put it into decimal. So we're going to go the other way. So the easiest way to kind of take a look at this is if we look at the example here. We have 0, 1, 1, 0. And remember, the subscript of 2 tells us it's binary. So we're going to write it into its decimal equivalent. So since binary has a base 2, we're going to take these numbers and raise them, okay, to a power of 0 to however many we have. So if we follow this step by step, you will not go wrong. If we have 0, 1, 1, 0, notice underneath each one there's 2 to some power. 2 is the base. You will always start with the right hand side, and you'll always start with 2 to the 0, and then you will increment the exponent on that 2 for however many binary digits that you have. So notice we go from 2 to the 0, 2 to the first, 2 to the second, 2 to the third. If we had another one, it would be 2 to the fourth. And we keep incrementing that exponent for however many decimals we have, or digits that we have. Alright, so what we're going to do is we're going to take each base of 2 to whatever that exponent is, and then we're going to multiply it by the given digit. Okay, so we're going to take, we're going to take 2 to the 0. 2 to the 0 is 1, and 1 times 0, the binary digit 0, is 0. Alright, so that's the bottom line that I have there. Then we're going to go 2 to the first, which is 2. 2 times 1, which is 2, so we write that down. We're going to go 2 squared. 2 squared is 4. 4 times 1 is 4. And we're going to write that down on the bottom line there. And then we're going to go 2 cubed. 2 to the third is 8. 8 times 0 is 0. Okay, so what we're doing is we're taking those base 2 to the exponents, and we're going to multiply them by the binary digit and write them on that last line. And then we sum them all up. So essentially, we don't have to count any of the zeros because they aren't going to give us any values. But we can see that if we go 0 plus 4 plus 2 plus 0, that's going to give us 6. Alright, so the binary number 0, 1, 1, 0 translates to the number 6 in decimal. Now, make sure that you have this example written down as you see it. It will be very, very helpful for you as we move through this section and work through some other problems. Okay, so let's do this one. We're going to convert this binary number 10010 to its decimal equivalent. Alright, so we're going to start by writing the number down again, and then we're going to go from right to left. We're going to go 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. So we're incrementing that exponent for however many digits we have in binary. Alright, then we're going to multiply those out. So 2 to the 0 is 1, and then 1 times the binary digit 0 is 0. 2 to the first is 2. 2 times that binary digit that's red, which is a 1, is 2. Alright, we write that down. Then we have 2 squared, which is 4. 4 times 0 is 0, so we write down 0. And then we have 2 cubed is 8. 8 times 0 is 0. We write down that 0. And then we have 2 to the fourth, which is 16. 16 times 1 is 16. So now we add 16 plus 0 plus 0 plus 2 plus 0, and that tells us 18. So the binary number 10010 is the decimal equivalent of 18. Alright, so remember the subscripts just tell us if our number is in binary or decimal. Alright, let's do another example here. We have the binary number 0110101. Okay, once again we are going to move right to left with our base 2 raised to an exponent. So our lowest exponent is always a 0. That's the first one we start with. And then where do we stop? However many digits we have. This binary number has 1, 2, 3, 4, 5, 6, 7 digits. So we are going to go all the way up to 2 to the 7, right? Or 2 to the 6, because we have 7 digits, but we go 0, 1, 2, 3, 4, 5, 6 when we do this. Okay? So we always start at 0, so it'll be 2 to the 0 times 1. So 1 times 1 is 1. And then we have 2 to the first, which is 2. 2 times 0 is 0, so we write down 0. We have 2 squared, which is 4. 4 times 1 is 4. Then we have 2 cubed, which is 8. 8 times 0, which is that binary 0, right, is 0. We have 2 to the 4th, which is 16. 16 times 1 is 16. We have 2 to the 5th, which is 32. 32 times the binary 1 is 32. Alright, and then we have 2 to the 6th, which is 64. 64 times 0 is 0. So remember, you're taking whatever that 2 to whatever that exponent is, you're taking that value and you're multiplying it either by the digit 0 or 1, whatever there is in that specific binary digit that we're dealing with. And then we add them all up. So we have 0 plus 32 plus 16 plus 0 plus 4 plus 0 plus 1. That equals the number 53 in decimal. Alright? Please remember, once again, you don't, on the tests or things like that, you don't have to type into the computer the subscript of 2 or the subscript of 10 for binary or decimal. But we do have to write that, so you don't mistakenly write, a binary out as a decimal or things like that. Alright, this is where I want you to work through these on your own. I'm going to post the right answers here as soon as I'm done talking. But write these down, give these a shot on your own, see if you can duplicate what we did in the examples. Alright, so go ahead and pause the video, write these down and do them, and then I'm going to give you the answers. Alright, so A, the binary number 0110, alright, becomes 6. Binary number B, or B is what we're looking at here, binary number 11010 translate to 26 in decimal. C, the binary number 01100101 translates to 53 in decimal. And D, right, 11010011 translates to 210 in decimal. So hopefully you got those. If not, email me. We can go through a few more or ask some questions in class. Okay? So what do we really need to do here? And in your notes, just write this down. Alright? When we are going decimal to binary, we're going to do successive division by 2. Alright? And then we have to write it from MSB up to LSB. And then on the bottom part here, if we're going to go binary to decimal, we're going to do what we call weighted multiplication. Alright, weighted multiplication, because we're going to use that base 2 to however many exponents we have, and then you have to multiply it by the binary bit. And then sum up all those products that you did. Those are the last few examples we did. Okay, we'll do a few more examples in class on the board, just so that you guys get a good feel for this. Really good to know how to go back and forth between this number system. We are going to see this again in mechatronics. When we get into PLCs and programming PLCs, we need to make sure that we can recall what we're doing here. And if you take my MTSU course of Digital Fundamentals, we will review this again there as well, get heavier into our digital circuitry. Okay. All right, Joe, remember, email me with any questions or write them down, and when you come to class, we can go over them on the board. Else, you got an online assignment to do with this, and we'll see you guys in class. Have a great night.